So this is how we're going to do that. We're going to first go to the graphing calculator, and we're going to graph in the Y1 position, Y1 is equal to x squared. And then we're going to set the graphing window to these specific dimensions. And the way that I started this window, so that you'll know how to replicate this at some future point in time if you need to, I started out with a zoom and then chose option number 4, which is zoom square. I'm sorry, not zoom square, zoom decimal, zoom DEC. And what it actually takes you to is a window that goes from negative 4.7 to positive 4.7 for the x's, and to negative 3.1 to positive 3.1 for the y's. And then I just basically altered that by changing the minimum value for x to 0 and leaving the maximum alone, and then changing the minimum value for y to 0, and then multiplying 3.1 times 2 to get the 6.2. And the nice thing about this is it keeps the window square, so that what you see on your graphing calculator actually looks like what you would graph on a piece of graph paper. And the other thing is that it allows us to have a nice, neat tracing window, because when we advance 1 pixel at a time, it's advancing the screen value by exactly 1/10. So first we want to write, as I said, the slope of a tangent line. And that tangent line is going to connect the points 3, 9, and 1, 1, which we've actually already done that. So 1 squared is 1, and 3 squared is 9. And that gave us 9 minus 1 divided by 3 minus 1 was 2, which gave us 8 over 2 and came out to be 4. But then, using our table and asking for specific values, what we're going to do is we're going to go to the table and ask for it to let us have x is equal to 1.9. And when it does that, it's going to tell us that at 1.9, the value of x squared is 3.61. And the value of 2.1 squared is 4.41. And so the difference in the y values is 4.41 minus 3.61. And 2.1 minus 9 is actually 0.2. And so what that's going to give us is a difference of 0.8 divided by 0.2. And when you divide those, you're going to see that what you get is actually 4. And that should be somewhat interesting, considering that we also got 4 for the last one. But now we're going to use the table. And when x is equal to 1.99, we see that the y value is 3.9601. and that when x is 2.01, the y value is 4.0401. And so when you subtract 4.0401, minus 3.9601, and 2.01 minus 1.99, for the denominator you'll get 0.02, and for the numerator you will get 0.08. And when you perform that division, you'll see that you again get 4. So we will continue the table onward. And when x is 1.999, we see that y is 3.99601. And when when x is 2.001, we see that y is 4.004. And when we subtract, I think what you're going to see is that you get 0.008 divided by 2.001 minus 1.999 is 0.002, which again comes out to be 4. And at this point, you should be saying, well, I can see where this is going. But just in case you can't, we will add one more 9 to the 1 and get 1.9999, and we'll square that, and we get 3.996001. And then we will also add another 0 between the 2 and the 1 after the decimal to get 2.0001, and 2.001 squared will give us 4.00400. And once again, the difference here is going to give us 0.0008, and the difference between 1.999 and 2.0001. And we're going to divide 8 10,000ths by 2 10,000ths, and again, that ratio is 4. So here's the question. What is happening here? Well, there's a couple of things happening. We are letting x approach 2 from the negative, and we're letting x approach 2 from the positive. And we're finding that the limit, when we calculate the slope formula, as x approaches 2, for that slope formula, delta y over delta x, that limit is approaching 4, and in fact it equals 4. So it shouldn't be surprising. This is a preliminary lesson, or a pre-lesson if you would, for section 11.3. And here we have a graph of the line y equals x squared. And we have a very narrow window of this line, y equals x squared. And what I would like to do first is talk about finding a rate of change for this line, y equals x squared. And the kind of rate of change I want to find here is called the average rate of change. And it is also the slope of a secant line. And this green line is a secant line. And even though I've kind of missed the points deliberately, it is the secant line that connects the points 1, 1 and 3, 9 on that line. And of course it wouldn't be hard to find the slope of that secant line, because that would be 9 minus 1 over 3 minus 1, which would be 8 over 2, which would be 4. So the slope of that secant line is 4. But what I'm really interested in finding is the slope of a tangent line. So I'm going to draw that tangent line. I'm going to try very hard for that tangent line to touch my curve in only one point. And so the line that I have now is called a tangent line. And what I would like to happen is I would like to be able to find the slope of the curve, which would be the same as the slope of that tangent line, at the point 2, 4. And that's not as easy as finding the slope of the secant line, because I only have one point. So what we're going to do in this little pre-lesson is we're going to talk about how we could perhaps be able to use the slope of a secant line to estimate the slope of that tangent line. And the way that we're going to accomplish this is we're going to slide the points closer and closer and closer to 4 by letting first, let's say, x equals 1.9, which might be right about here. And then let x also be 2.1, which would put it right along about here. And try to connect up those 2 points with a secant line. And what we see is that that secant line is very, very close to that tangent line. And if we slid the points closer and closer and closer, until we couldn't distinguish the difference between the 2 points and the 0.24, we would be able to approximate the slope of the tangent line. That the slope of the tangent line at the 0.24 is also 4.